Welcome to Manufacturing Processes, Machining and Machine Tools lectures by Professor Joyjeet Ghosh. This is the 18th lecture of a series of lectures. This lecture will be on grinding, part 2. He will be discussing about the grinding processes like surface grinding, cylindrical grinding, plunge grinding, centerless grinding, through feed grinding, and feed grinding, internal grinding, creep feed grinding and tool and cutter grinding. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this lecture. In this lecture we'll be discussing about the grinding processes. This is the second part of the grinding lecture. In case you have not seen the first part, I recommend you to see the first part of this lecture and then you come and watch this video. So in this lecture we'll be discussing about grinding processes. What are the different types of grinding processes? Basically we'll be discussing that. So grinding processes can be of 4 different types. Basically there are other processes also. The most important types are the 4 types: surface grinding process, cylindrical grinding process, centerless grinding process, and internal grinding process. Also there are tool and cutter grinding processes, there are creep feed grinding processes. All those we'll be discussing, but these 4 are the important ones industrially. So what is surface grinding process? Surface grinding process is basically a process of grinding to generate flat surfaces. The various ways in which we can generate flat surfaces. In the first example, that is A, you can see the grinding wheel is rotating about a horizontal axis and the workpiece is reciprocating. In the second case also, the grinding wheel is rotating about a horizontal axis. However, the workpiece is being held in a table and its number of workpieces are held in a table are rotated under the wheel. In the third case, that is number C, you can see the grinding wheel is rotating at about an axis which is perpendicular to the workpiece surface, and the workpiece is reciprocating. In the second or third and fourth rather, the number of workpieces are held and are rotating, and the grinding wheel is rotating about a vertical axis. And notice that in the horizontal axis rotation, the cutting edges, the grind abrasives, are on the periphery of the grinding wheel, whereas in the C and D, where the grinding wheel is rotating about a vertical axis, the abrasives are the abrasives which are removing the material from the workpiece are on the face of the grinding wheel. So this is about surface grinding. The workpiece in feed you can grip. You can see this is a transverse grinding, so feed will be given in this direction. And if it is a plunge grinding, so here plunge grinding, the feed will be given in a radial direction. In radial direction the feed will be given, and the shape of the wheel will be on the workpiece, produced on the workpiece. And you can see it is rotating vertically about vertical axis, and number of workpieces are held, and simultaneously large number of workpieces will be machined. So it is basically a process of generating flat surfaces. Okay, plunge feed already I have discussed. Okay, this is the table is normally electromagnetic table. The workpiece held in the electromagnetic table, and this is the wheel. The feed is given to the table. Table can move in X and Y direction, and this is rotated about this workpiece. So this is how it works. So this is the surface grinding machine we have in our. This is the electromagnetic table. This is the grinding wheel, and we can give feed in this direction and this direction. This is a CNC surface grinding machine. We have a CNC surface grinding machine in our shop. This is not the picture of that. The picture I have not included here. Okay, surface grinding processes. First you have to select a suitable wheel for the material, then align the part to the magnetic chart, turn on the spindle, coolant, hydraulic system, etc., etc. Set up the automatic cross feed, set up the table speed, adjust the length of the stroke, stop the coolant, start the table travel, carefully lower the wheel until it touches the workpiece, turn on the coolant again, take a cut across the part by means of an automatic cross feed. At the end of the first grinding pass, stop the cross feed, and repeat the process if more passes are required. This is the basic algorithm of a surface grinding process. Okay, this is cylindrical grinding. Cylindrical grinding is basically used to produce cylindrical surfaces where a grinding wheel is rotated against the workpiece at a higher speed. The workpiece is also rotated, but the speed with which grinding wheel is rotating is also higher. It is at a very, very high speed. So it produces cylindrical surfaces which are of very high finish and of high accuracy. It can be done externally, it can be done cylindrically. Internally. It can be done externally and it can be done internally. So here it's just like a turning process where it produces cylindrical surfaces. The workpiece is held between centers, and the tool post carrying the single point cutting tool will be replaced basically by a grinding wheel. The machine looks like is very similar to that of a lathe machine. So you can see with a mandrel for lathe dog and faceplate, catch plate or faceplate. Normally we use a catch plate. So this is the workpiece and this is held, and this wheel can be moved about this traverse about this thing, or the workpiece the table can traverse either way. So I'll show you the cylindrical grinding that we have here. So this is the workpiece and this is the cylindrical wheel. The wheel is visible here. This is the cutting fluid application of cutting fluid nozzle, which applies the cutting fluid between this tool and the workpiece, and you can see the lathe dog is used for holding this workpiece between two centers. This is the live center, this is the dead center. Okay, so this wheel can be moved about the length, cross length. Likewise, now if you move about this cross length, it is called transverse feed cylindrical grinding, and if we do not meet, rather feed will be given in this direction, then we call it's a plunge cut or plunge feed cut. So it is similar to that of surface grinding also. We do this in surface grinding also. So this is a transverse feed and plunge feed surface grinding, and this is the thread grinding. And then we have centerless grinding. In centerless grinding, basically we do not use centers, therefore it is called centerless grinding. Unlike the cylindrical grinding process, here we do not use centers. We just place the workpiece between the two wheels. One is the grinding wheel, other is the driving wheel. The driving wheel is normally made by tough rubber bonded wheels, and there is a work rest on which the workpiece is placed. So the workpiece is held between these two wheels, and the driving wheel or the regulating wheel is slightly tilted to give a transverse feed to the workpiece as the grinding is being done. Now the main advantage of this type of grinding is that the work holding does not take time, and a large number of workpieces can be produced in a very short span of time. So it can be, again, it can be from a single, it can be external cylindrical grinding, and it can be internal cylindrical grinding also. You can see here, this is the regulating wheel is slightly tilted for transverse feed. So this is internal centerless grinding. Two support wheels, this is the grinding wheels and this is the regulating wheels. It will move in this direction. CNC centerless grinding machines are also available. So there is a three type: through feed type, plunge grinding, and there is end feed type also. So in through feed type, it will move in this direction. In plunge feed, it will move radially. So this is normally used for grinding of bolts, etc., etc., which creates problems in moving in transverse direction. And there is end feed. So this is mainly used for tapered cylindrical grinding workpiece. So through feed. So this is a through. This is the end feed. Sorry, this is in feed or plunge feed. So the feed is given in this direction, and this is a tapered feed. So this is end feed. In end feed, there is a stopper, and grinding wheel is rotated, and this workpiece moves and stopped at a particular point. So this is particularly used for taper workpieces. And there are other types of grinding processes also there. These are the centerless grinders. Advantages of centerless grinding, limitations. Internal grinding is also important. It can be cylindrical internal grinding, and it can be centerless internal grinding also. And then we have creep feed grinding. It's a new form of grinding invented in around 1958. Creep feed performed where high depths of cut and very low feed rates are required. Hence the name creep feed. So large volume of material is removed here, and the depth of cut may go up to around 6 mm. This is extremely high, although but 1 mm, 2 mm are easily cut in centerless grinding. Normally we do not perform creep feed grinding in a conventional grinding machine. Rather, we require a special form of grinding machine which has higher power and higher stiffness and damping capacity, and variable and well controlled spindle and work table speeds. So that is required for creep feed grinding. So this is a conventional grinding process. Small volume of material is removed, and you can see the depth of cut here very small, and here you can see the depth of cut here very large. Although it is exaggerated, however, the depth of cuts are quite large in creep feed grinding. And this is 1 to 6 mm size varies around for creep feed grinding. And we have tool and cutter grinding. This is a tool and cutter grinding machine which we have in our lab. This is used for grinding single point cutting tools, mainly HSS cutting tools. So with this we come to the end of different types of grinding processes. I hope you have liked this video. In case of any doubts and any confusion, please feel free to contact me through the comment box, or you can email it to me. Thank you for watching this video.